Hello, welcome to QuickHit number 4 about cube sparsity and query performance. In this I'm going to talk about one of the best practices, which is to keep your cube sparse and explain why, and then I'll actually show you a working example of how this affects query performance, not in every case, but in a lot of cases, and of course in this example. So the first thing to talk about is the best practice, which is to keep your cubes sparse. Now, if you're not familiar with that, if you think about a very simple example, you have customers, products, and time, just those three dimensions, customers, products, times, and you're tracking sales. Not every customer buys every product every day. In fact, if you had 10,000 customers, 100,000 products, and we're tracking data for, let's say, approximately 3 years, 1,000 days, then the chances of each customer buying each product every day are almost zero. Chances are a customer might buy one or two products several times a year at most. That would be about it. So if you took a particular product and a particular customer and a particular day at random, chances are there's no data there. So it's null. And analysis services does not store anything for a null cell. Now, when you are doing queries, and if your cube is sparse, as most cubes are, then if your query requires any calculation, by default, a calculation has to be done on any cell that is not null. And that's one of the reasons why you want to keep the cube as sparse as possible. Also, of course, keeping storage size small, and there are some other good reasons for doing that. But by keeping the cube small, these calculations only have to be applied to cells that actually have a value, and you'll get much better query performance. But one of the problems I see people make over and over is they don't want to show a null cell. They want to put a value in there, such as 0. So take a look at this first sub-bullet point here. It says don't do this, and it uses the immediate if function. A certain condition, if it's true, then you give an expression. Otherwise, you stick a 0 in there. What you're doing in this case is making the cube very dense. You're populating every empty cell with a 0. Suddenly it has a value, and therefore a calculation would have to operate on this. The answer here is to use something called format string, and I will show you that format string in a moment, what it looks like, and we'll talk about why you would want to use that, and you'll see a working example. Also, it's important to understand how analysis services works with nulls. If I have a measure, let's say the sales on a particular day for a particular customer for a particular product, if that is null and I multiply, I still get a null value. If I divide, I still get a null value. But if I add or subtract, I get an actual value. That null gets treated as 0. Now, I'm sure there's a good reason why that is. I don't know why it is, but it's important to know that. So if you happen to just say +1 to every value, to every cell, then suddenly you have a very dense cube. You're not sparse like you want to be. So it's important to keep cubes as sparse as possible and not do things like that immediate if condition there, where I'm putting a 0 in for all null cells. So as I mentioned, a calculation has to be done across every non-empty cell. Therefore, we don't want to make this dense by putting a value in every cell. And you can catch this a lot of times. First of all, the query is just slow, but it's fairly easy to catch using the performance monitor and looking at the number of cells being calculated. So let's take a quick look at this and see exactly what it looks like in practice. Here I am in SQL Server Management Studio, and I have a sample query here that works against the AdventureWorks sample from Microsoft. Now, this is not a query I came up with. I saw this presented by a couple of guys from the Analysis Services product team, and they said they in turn had borrowed it from someone else. But it's kind of a strange query. Let me explain what it's doing. I want to take all of my months. You can see months.members here. And I want to take all of my cities, cities.members. So for every city, for all of the months in my cube, I want to know the number of products that were sold in which I sold more than $1,000 worth of that product. I don't care what product it was. I just want to know how many products I sold in that city that month where I sold over $1,000 worth of that product. So at the top is a calculated member, simply called X, just a simple example here. And it's the sum of the product members, so the individual products, and then there's an immediate if. If the internet sales amount is greater than 1,000, we're going to give to 1, otherwise a 0. Now this is the bad case. This is the case where I am making this dense. I'm putting a value in every possible cell. Therefore, this calculation is going to have to iterate over every one of those cells. So to see that in action, I'm running Performance Monitor here. And under the MSAS 2008:MDX group, there is a total cells calculated performance counter that I'm tracking. And right now it's 0. I restarted the analysis services engine on this in this virtual machine so that I could reset that to 0 just so you could see. So at this point I will return to my query, and I actually have a query above it to clear the cache, but I won't worry about that at this point in time since I just restarted the engine. There is nothing in the cache. So I'm going to start the execution of the query. And while that's running, if I bring this up, you'll notice that the total cells being calculated is incrementing at a fairly rapid pace. So I'm going to let this run, and I'm actually going to pause the video until it's finished, and then we'll take a look at where it ends up. And the execution of the query is done. You see that it calculated about 9.1 million cells. And down here at the bottom, it took 1 minute and 9 seconds to run. If I look at the results, you can see this is what it looks like. And anywhere you see a 0, that means that it should have been null. And while it looks like there are not a lot of null values here, if I scroll down, it doesn't take long before you see that, sure enough, all of these would have been empty. And therefore, I ran this query, and it took 1 minute 9 seconds. It calculated 9.1 million cells. So let me come back up here. First thing I'm going to do is just very quickly clear the cache so that we do get a valid query the next time, and nothing in the cache helping out. But what I want to do now is change this to null. And I'm going to re-execute this. I will get the same values, almost identical. I'll show you in a moment, and then we'll fix it. But I want you to notice, out of 9.1 million, watch now how many cells I calculate and how long it takes. Okay, the results are back in the background. You can see it took 6 seconds, and I didn't even calculate 100,000 cells. In fact, I only calculated about 23,000 approximately. So from 9.1 million down to 23,000, you can see obviously a huge decrease, which is good. Both a much faster query and far fewer cells being calculated. But now notice that ugly null is stuck in all of these cells. And you see these huge settings with nulls in it. Well, again, this is where that format string comes into play. And I just happen to have the format string command in the clipboard, on the clipboard. And the way this works is that basically this is the value to show for a positive number, a negative number, I forget the third argument, and then the fourth one is what to put in if the value is in fact null. So at this point, if I simply clear the cache and re-execute the query, I won't calculate any more cells. I'll calculate roughly another 23,000, and I'll show that to you. The time should be approximately the same. So notice here, again, around another 23,000. Took 6 seconds again. But now the results look identical to what I had before. So in conclusion, keep those cubes sparse whenever possible. I recently worked with a customer where they were logging absences of students. And so if a student was absent a full day, it was 1. If they were absent, let's say, 2 out of their 6 periods, they'd get a 0.3. 333. They were absent 1/3 of the day. But if they weren't absent at all, they wanted to put a 0 in all those cells. So every day, every student would have a value. And I said, no, we don't. That would be a completely sparse cube. There would be, or a completely dense cube. There would be no sparsity to it at all. I said, you don't want to do that. You only want to put a value in if it's not that 0 that you're wanting to track. Also, it's important when you build calculations to make sure they're optimized for sparse cubes. There are some calculations. I could have done a count over a filter, and I'll show that in some future videos probably, in which case it would have put a 0 in automatically for everything, and it would have taken just as long as when I used the immediate if with a 0 in it. So it does help to work with these calculations, and there's some documentation on which ones have been optimized for what they call subspace computations or subspace calculations. There are different terms for it, but there are things that will calculate first and not have to calculate cell by cell, but they'll calculate just for the cells that have values. And learn to use the performance monitor there. That's just a simple trick. It's just, again, one counter, the total cells calculated, but it makes a huge difference when you're looking at this to figure out what is really going on here. And clearly we didn't have that many answers. You could have run a similar query on the relational engine to see how many results should have come back. And you can see that we had approximately 23,000 cells with values, and yet the first time I ran it I calculated over 9 million cells. So learning to use Performance Monitor will help you find and eliminate some of these problems. Thank you.